When we look for the limits of mechanical power, our minds usually look up. We imagine machines built to tear through the atmosphere or escape gravity entirely. Think of the F1 engines that pushed the Saturn V to the moon. A single combustion chamber burned thousands of kilograms of fuel per second to generate 1.5 million pounds of thrust, dwarfing the human standing directly beneath it. Or consider the Kuznetsov NK-12 driving the Soviet-era Tu-95 bomber. Those contra-rotating propellers, two sets of 4 blades spinning in opposite directions, produce an acoustic signature so intense that submarines can detect it from hundreds of kilometers away. These machines are famous for their noise and their speed. But the most powerful internal combustion engine ever constructed doesn't fly. It operates entirely out of sight, locked in a room at the bottom of the ocean. To understand the Wärtsilä RT-flex96C, you have to start by looking at the internal volume of just one of its cylinders. It has a bore of 960 millimeters, wide enough for a person to stand straight inside the combustion chamber. But this single chamber is just a fraction of the engine. The full unit links 14 of these massive rooms into a single row. Inside those chambers, the Wärtsilä burns heavy fuel oil. This is the thickest, most energy-dense petroleum product available, the residue left over after refineries extract gasoline and diesel. Burning a fuel that thick requires immense heat and internal surface area. This configuration is designed specifically to extract work from a waste product that most other engines cannot even ignite. Zooming out to look at the complete footprint, the proportions are staggering. The engine stands 13.5 meters tall and 26.6 meters long, as high as a 4-story building and longer than a standard semi-truck. Fully assembled, the metal structure weighs 2,300 tons. This mass is a functional requirement, providing the structural inertia needed to dampen the vibration and torque generated by 14 massive pistons moving in sequence. Those forces produce a mechanical output unmatched by any other diesel engine in existence, 107,390 horsepower at maximum capacity. You don't install an engine with these dimensions into a vehicle. Instead, the shipyard lays down the engine block first and then constructs a massive steel hull around it. The engineers who designed it weren't optimizing for acceleration. They built it to this size because they needed a machine capable of unyielding, continuous endurance. That record-breaking horsepower figure comes with a mechanical contradiction. Despite generating immense energy, the engine appears to be moving in slow motion. At full throttle, the crankshaft turns at just 102 revolutions per minute. The pace is so deliberate, you could count the revolutions with your eyes. This slow rotation is the key to its reliability. By keeping the RPM low, Wärtsilä minimizes friction and heat on the cylinder walls, allowing the engine to run without stopping for months between service intervals. In the realm of industrial marine transport, mechanical power is not measured by velocity. It is measured by the ability to deliver a relentless, uninterrupted push across vast stretches of time. When we pull back from the engine room to look at the vessel itself, the purpose of that relentless push becomes clear. The ships powered by the RT-flex96C are floating steel warehouses, stacking up to 11,000 standard shipping containers across the main deck. That single engine is responsible for hauling that entire payload, plus the weight of the hull, across the Pacific Ocean in a single, unbroken voyage. This specific combination of massive displacement and low RPM allows a ship to move bulk cargo with a fuel efficiency that makes intercontinental trade profitable at a global scale. When these ships reach these sprawling port terminals, they offload the electronics, clothing, and materials that fill our daily lives. The millions of people buying those goods will never see the machine that delivered them. It remains hidden deep in the hull, performing the heaviest lifting in human history while remaining unacknowledged by those it serves. or touch the moon. But the reality is that the modern world is sustained by a 4-story mechanical giant, turning slowly at the bottom of the sea.